Hi there. Welcome to our session on Oracle Database Administrator. In this session, we will learn about Oracle Automatic Storage Management known as ASM. So let's start the session. ASM is a volume manager and a file system for Oracle database files that support single-instance Oracle database and Oracle Real Application Clusters, Oracle RAC, configurations. ASM is Oracle's recommended storage management solution that provides an alternative to conventional volume managers, file systems, and raw devices. ASM uses disk groups to store data files. An ASM disk group is a collection of disks that ASM manages as a unit. Within a disk group, ASM exposes a file system interface for Oracle database files. The content of files that are stored in a disk group are evenly distributed, or striped, to eliminate hotspots and to provide uniform performance across the disks. The performance is comparable to the performance of raw devices. You can add or remove disks from a disk group while a database continues to access files from the disk group. When you add or remove disks from a disk group, ASM automatically redistributes the file contents and eliminates the need for downtime when redistributing the content. The ASM Volume Manager functionality provides flexible server-based mirroring options. The ASM Normal and High Redundancy disk groups enable two-way and three-way mirroring respectively. You can use external redundancy to enable a redundant array of inexpensive disks, RAID, storage subsystem to perform the mirroring protection function. ASM also uses the Oracle Managed Files, OMF, feature to simplify database file management. OMF automatically creates files in designated locations. OMF also names files and removes them while relinquishing space when table spaces or files are deleted. ASM reduces the administrative overhead for managing database storage by consolidating data storage into a small number of disk groups. This enables you to consolidate the storage for multiple databases and to provide for improved I/O performance. ASM files can coexist with other storage management options such as raw disks and third-party file systems. This capability simplifies the integration of ASM into pre-existing environments. Oracle Enterprise Manager includes a wizard that enables you to migrate non-ASM database files to ASM. ASM also has easy-to-use management interfaces such as SQL*+, the ASM command line interface, and Oracle Enterprise Manager. Now let's understand the concepts of ASM. There are 5 concepts of ASM, we will discuss each in details. For now let's have a look on the concepts. ASM instances, ASM disk groups, mirroring and failure groups, ASM disks, and ASM files. Let's start with ASM instances. An ASM instance is built on the same technology as an Oracle database instance. An ASM instance has a system global area, SGA, and background processes that are similar to those of Oracle database. However, because ASM performs fewer tasks than a database, an ASM SGA is much smaller than a database SGA. In addition, ASM has a minimal performance effect on a server. ASM instances mount disk groups to make ASM files available to database instances. ASM instances do not mount databases. ASM metadata is the information that ASM uses to control a disk group, and the metadata resides within the disk group. ASM metadata includes the following information: the disks that belong to a disk group, the amount of space that is available in a disk group, the file names of the files in a disk group, the location of disk group data file data extents, and a redo log that records information about atomically changing data blocks. ASM and database instances require shared access to the disks in a disk group. ASM instances manage the metadata of the disk group and provide file layout information to the database instances. ASM instances can be clustered using Oracle Clusterware. There is one ASM instance for each cluster node. If there are several database instances for different databases on the same node, then the database instances share the same single ASM instance on that node. If the ASM instance on a node fails, then all of the database instances on that node also fail. Unlike a file system failure, an ASM instance failure does not require restarting the operating system. In an Oracle RAC environment, the ASM and database instances on the surviving nodes automatically recover from an ASM instance failure on a node. Figure shows a single node configuration with one ASM instance and multiple database instances. The ASM instance manages the metadata and provides space allocation for the ASM files. When a database instance creates or opens an ASM file, it communicates those requests to the ASM instance. In response, the ASM instance provides file extent map information to the database instance. Now let's discuss about ASM Disk Groups. A disk group consists of multiple disks and is the fundamental object that ASM manages. Each disk group contains the metadata that is required for the management of space in the disk group. Files are allocated from disk groups. Any ASM file is completely contained within a single disk group. However, a disk group might contain files belonging to several databases, and a single database can use files from multiple disk groups. For most installations you need only a small number of disk groups, usually 2, and rarely more than 3. Disk group components include disks, files, and allocation units. Figure shows the relationships among ASM disk group components. Oracle mirror and failure groups. Mirroring protects data integrity by storing copies of data on multiple disks. The disk group type determines the mirroring levels with which Oracle creates files in a disk group. When you create a disk group, you specify an ASM disk group type based on one of the following 3 redundancy levels. Normal for 2-way mirroring, high for 3-way mirroring, and external to not use ASM mirroring, such as when you configure hardware RAID for redundancy. The disk group type determines the mirroring levels with which Oracle creates files in a disk group. The redundancy level controls how many disk failures are tolerated without dismounting the disk group or losing data. ASM mirroring is more flexible than traditional RAID mirroring because you can specify the redundancy level for each file. 2 files can share the same disk group with one file being mirrored while the other is not. If you omit the failure group specification, then ASM automatically places each disk into its own failure group. Normal redundancy disk groups require at least 2 failure groups. High redundancy disk groups require at least 3 failure groups. Disk groups with external redundancy do not use failure groups. Now let's talk about ASM disks. ASM disks are the storage devices that are provisioned to ASM disk groups. Examples of ASM disks include a disk or partition from a storage array, an entire disk or the partitions of a disk, logical volumes, and network attached files, NFS. When you add a disk to a disk group, you either assign a disk name or the disk is given an ASM disk name automatically. This name is different from the name used by the operating system. In a cluster, a disk may be assigned different operating system device names on different nodes, but the disk has the same ASM disk name on all of the nodes. In a cluster, an ASM disk must be accessible from all of the instances that share the disk group. If the disks are the same size, then ASM spreads the files evenly across all of the disks in the disk group. This allocation pattern maintains every disk at the same capacity level and ensures that all of the disks in a disk group have the same I/O load. Because ASM load balances among all of the disks in a disk group, different ASM disks should not share the same physical drive. Oracle ASM files. Files that are stored in ASM disk groups are called ASM files. Each ASM file is contained within a single ASM disk group. Oracle database communicates with ASM in terms of files. This is identical to the way Oracle database uses files on any file system. You can store the following file types in ASM disk groups. Control files, data files, temporary data files, and data file copies. SB files. Online redo logs, archive logs, and flashback logs. RMAN backups. disaster recovery configurations, change tracking bitmaps, and data pump dump sets. Now let's see an example to create Oracle instance. Watch the example carefully and follow the steps. Hope you liked the video. We will get to know more topics in our upcoming sessions. Till then, thank you.